Hey everybody, Miss Dietrich here. We're going to explore the relationship between area of parallelograms and the area of trapezoids. Now, what I've done here is I've taken these are two trapezoids. I'm just going to rotate this around so you can see that they're equal and congruent. See, that's the same trapezoid. If I take that trapezoid and I rotate it around, flip it, and put it together to form a parallelogram, then we have, what you see here. All right, so if we were to go ahead and find the area of this, which is a parallelogram, when you put the two trapezoids together, wouldn't we use this formula, area equals base times height? And wouldn't we be adding, to get the base, we would be adding this dimension and this dimension? So this is 10, and this dimension right here would be 4. And if I add 10 plus 4, that would give me the 14, which would be the length of this whole thing. The height, recall, is always perpendicular to the base. So that would be right here. See, it's 1, 2, 3. And if we multiplied 14 times 3, we would get 42. So the area of this parallelogram is 42 square units. Now, if we were to focus on just one of them, so I'm just going to put this away for a minute, and talk about how would we find the area of this trapezoid, we would use this formula. Now, one thing that we could do is we could also just say it's half of a parallelogram and take half of this and get the answer that way. But let's explore if we were to use the formula for area of a trapezoid. The area of a trapezoid is half of the sum of the parallel sides, which we call base 1 and base 2, times the height. And if we substitute in the values, we would say we would call one of the numbers. Doesn't matter which one you call base 1 and which one you call base 2. So let's say you want to call this base 1, so you substitute it in. Here's base 2, substitute it in, times the height, and recall that the height is still perpendicular to the base. We would add these two things together and get the 14. Now that should look familiar because that formed the length of the bottom piece here of the parallelogram. If we did half of 14, we would get 7, and if we did 7 times 3, we'd get 21. Now earlier we said that a trapezoid is a half of a parallelogram, so another way to get to this 21 is to just take this 42 and say to yourself, I have to take half of it, or divide by 2, it's the same thing. Those two things are the same thing. And if you did that, then you would get the answer for the half of it, or the trapezoid. Now let's take a look at another example that's kind of similar. Let's look at one that looks a little different in shape. This one does. So this is a trapezoid right here, what I'm tracing. Why is it a trapezoid? It's because it's a quadrilateral, and it has just one pair of parallel sides. See, this is parallel to this. Now let me rotate this around just to show you. Oops, wrong thing that I wanted to move. This is what I'm trying to do. All right, so if I show you that this is the same trapezoid, just put it over top so you can see. If I rotate that around and move it over like that, do you see how it forms a rectangle? Now if I was interested in finding the area of that rectangle, if this is 9, that means this is 9. And if this is 6, that means this is 6. If we were to find how long this whole line is, we would add these two numbers together, and wouldn't that be 15? And this is the height, because it's perpendicular to the basis of 5, and we would multiply that together and get 75. Now, if we're interested in half of that, which is what a trapezoid is, if we're interested in just this, or this for that matter, we could just take half of 75 and get the answer that way, or we could apply the formula. We could apply the values to the formula for area of a trapezoid. So what are the parallel sides again? They're 9 and 6, so you substitute those in for base 1 and base 2. The height is still here, 5. We add the parallel sides and we get 15. And then I would take half. If there's an even number, that's nice, but these are both odd numbers, so I just took half of 5 because I could do that in my head, and I get 2.5. And if we multiply 2.5 times 15, we should get the same thing that we got right here. So let's just make sure. Here we get the 25, 10 and the 2 more is 12, put the 0 to hold our place. Here we get the 5, here we get the 2, and if we add things up together, here we get the 5, the 7, and the 3, and we have to go over 1 and go over 1. So we get the same thing. We still get area equals 37 and 5/10 square units.